In this paper by Meta AI, we present Emu Video Edit, a state-of-the-art video editing model trained without supervised data. In the task of video editing, the model is given a video and a free-form editing instruction, such as transform into a panda, add a Santa hat, with a fireman uniform, at New York, or even segment the video. Our key insight is that we can decouple expectations from a video editing model into two criteria. The first is precisely edit each individual frame, and the second is to ensure temporal consistency among the edited frames. In practice, we leverage Emu Edit converted into a ControlNet-like architecture, and Emu Video, both trained as adapters over the same frozen text-to-image Emu model. While the Emu Edit and Emu Video are trained separately, each on its own dataset, at inference time they can both be attached to the text-to-image model and be inferenced jointly. However, this joint inference results in unsatisfactory edits. On the other hand, this joint model does contain the relevant weights for image editing and video generations in the adapters attached to it. Therefore, we hypothesize that the adapters are not aligned to each other, and that a short alignment phase might be sufficient to fix this deviation. We propose Factorized Diffusion Distillation, an unsupervised alignment procedure. In the middle row, we can see the student, initialized by the text-to-image with both adapters attached. This student generates a video from complete noise by performing multiple diffusion steps. During training, this output goes into two SDS distillation losses, one for the image editing teacher and the other for the video generation teacher. Additionally, we add a discriminator for each teacher where the fake samples are given by the student and the real samples are generated by the actual teachers. In order to preserve memory, we only train LoRa layers over the student's text-to-image backbone. Additionally, the student performs only 3 diffusion steps during training. In order to not overfit these 3 time steps, we suggest K-bin diffusion sampling. We split the T diffusion steps into 3 evenly split bins. At each training iteration, we randomly select a step from each bin. This solves the train test discrepancy, and we can sample and inference using any number of steps. We call the resulting model Emu Video Edit, or in short, EVE. EVE is state-of-the-art in text-based video editing, capable of performing all 16 editing tasks that Emu Edit presented. For evaluation, we leverage the TGVE dataset. While TGVE includes only 4 types of editing tasks, we extend the dataset with 3 additional tasks: add, remove, and inpaint, all over the original videos in TGVE. We release this new dataset and refer to it as TGVE+. We can see that EVE outperforms all baselines, both in automatic matrices and in human evaluation. We perform an ablation study demonstrating the importance of all components in EVE. This includes initializing the student with the pre-trained adapters, applying the alignment phase, including the SDS losses and the discriminators, and finally the effect of the K-bin sampling technique. While we align the adapters using only classic image editing instructions, we found out that the student can perform also the computer vision tasks suggested in Emu Edit, such as depth, sketch, segmentation, detection, pose estimation, and more. This strengthens the belief that the proposed pipeline is just an alignment phase and doesn't learn something new. Theoretically, FDD can be applied to any amount or type of adapters. For EVE, we use the ControlNet adapter for image editing and a temporal adapter for video generation. Here, we examine applying FDD to another combination. The first is Emu Edit, while the second is a LoRa-based adapter trained for personalization or style. As can be seen in this slide, applying Emu Edit alone has no effect, as it has no knowledge of the subject or style. Combining the adapters without an alignment phase demonstrates reasonable results. However, leveraging FDD to align the adapters results in edits which are subject or style aware. Thank you for listening.